Greetings. This is a quick tutorial about getting started with Kali Linux as well as Linux. I provided a brief agenda for this tutorial. So we're going to be basically going over Linux file structure, providing some helpful videos and further tutorials for those of you that are not very familiar with Linux, kind of getting foundational knowledge, and some further references for learning the Linux file system and being able to perform some basic tasks. After this component, we're going to jump into some common files and commands that we need to know for the Linux operating system. And these will be focused primarily in retrieving some system information, networking, and then leveraging some system basically graphical user interfaces for system tasks. Let's get started. So in this case we're using Kali Linux, which has a graphical user interface. To log in, we simply use the username root, R-O-O-T, with password Tor, which is root backwards. So we logged in and we see this interface. One of the important things about a Linux operating system is the fact that in Linux everything is treated as a file. So we can have a folder, that's a file. We can have a document inside this folder, it's also a file. We can have a process, it's also a file. And what I mean by this is that each file has a location. Everything is treated as a file. Each file has a location. By the same token, in Linux, we can have two files with the same name. So, as I mentioned, a file can be a folder. In this case, we have a folder, it's called new. So if we go and create a new folder, and we call it new lowercase, if you noticed, I can have two files, in this case, is a folder, with the same name. The difference, however, if you notice the naming. So this folder is all uppercase, and this particular one is lowercase. So in Linux, we have to be very specific regarding the file name. Which file name are we trying to access or use? We have to specify the exact casing of the file name, whether it's uppercase, lowercase, and so on, because, as I mentioned, two files can have identical name. So this being said, let's take a look into what the basic structure is for a Linux operating system. So to navigate, we can use the graphical user interface or the command line. What we're going to start with is the graphical user interface. On the left-hand side, we're going to go with Places. From Places, we will navigate to Computer. So left-click on Computer. We'll see this Explorer interface. From here, we're going to left-click on File System. And this reveals the essential file system for this particular type of operating system, or this flavor, I should say. So what we're going to do is we're going to provide a different visual. So I'd like to go to View and then scroll down until the List section. So left-click on List. And from here, you should be able to see some of the basic folder structure for this particular operating system. So looking at this /, this is an indicator that we are at the very root directory for this operating system. So the lowest level of the operating system. Everything else is located at this level. So these are basic folders that are like, let's say, the parents for the parent structure. Everything inside of them will be treated as a child. So looking at the top of this structure, we'll notice that we have the bin folder. And the bin folder is where different binaries are. So if we open up the bin folder, we'll see those binaries. So these are essentially different applications. Some of you perhaps recognize echo, grep, essentially searching, less, list, and so on. So some essential applications are located in the bin folder or binaries. So this being said, if we go back, we can actually use the arrow pointing to the left, go back to this hierarchy. What we're going to notice is the boot folder. So this boot folder is actually used during the boot process. So it's the bootloader files. If we open it up, we'll notice grub, some of the memory tests, and other essential configuration files. Now, as I mentioned, this is one way to navigate through the interface. So it's using the graphical user interface, and particularly the Explorer. However, we can also use the terminal. So it's a command line driven interface. So left click on the terminal, and what we'll do is we're going to type in pwd, which will print the working directory and tells it that we are at the root level. So if we compare side by side, let's do this. I'm going to restore the size of this window and kind of organize my windows here. So the Explorer, I'm going to put a side by side with this terminal window. So we're at the root level. So if we select the home folder, so it's highlighted, and then on the keyboard press R, we'll automatically scroll down to the root directory. So if we look inside root by double clicking, we will notice these basically files. So since we're into the root directory, in order to replicate this double clicking in the root directory and revealing the content inside this root directory, from the command line, what we need to do is initiate the list command. The list command is exactly the same thing as the double clicking on the root folder itself. So with ls, what we're doing is revealing the command line representation of the same list of folders inside, actually files inside the root folder. So everything is treated as a file, right? So look into the data, we see data, we have desktop, we have a test, which is right here. We have another test.exe right there, TypeScript. We have the Vone scan, and so on. Now, please note that your particular instance of Kali may be looking different than the one that I'm using for this presentation. That's okay. This is just to give you an idea of navigating through the graphical user interface as well as the terminal. Now let's go back to the root directory. So we were inside root, and perhaps we would like to further explore the structure with some of the foundational folders for the operating system. So, and I'm going to be using the term folder because I'm accustomed perhaps to the graphical user interface, and this is a symbol for folder. So coming from the Windows days, this really looks like a folder. Keep in mind that everything in Linux is a file. So what we're going to do is, if we look down the list, we will notice that there's other folders. So some of the more important ones are the, let's see, it says media. So the particular media folder contains information regarding removable devices. So in this case, it's a CD-ROM, and we have two instances. One of them, it looks like to be a shortcut. Okay, so another important area going down the list is the mount folder. So mount is if we have file sharing, for example, between Linux systems or Linux and Windows, we'll be using the mount folder to actually a mount directory, so we can retrieve and send and receive type of files. Okay, the SBIN. The SBIN is an interesting directory, and it pertains, actually contains information with system binaries. So inside this folder, you're going to find some system binaries. So these are system-related applications, so like cryptography setup, crypt disks, bed blocks, CF disk, and they're more like system-oriented applications, where bin was more like user-related applications, things that the user can execute. SBIN is more of system-related applications. Okay, so if we go back and, for example, go into what else is here? Temporary directory user, USR. So if we double click on it, we're going to see basically folders for different users. Okay. So these are actually user programs, not users itself. These are different user programs. Okay. So user programs. So the add user program is located within the USR folder. Apps, aptitude, applications. If we go on this side, so we're inside the user share folder. So to get there, first of all, we're going to change the directory. Okay. So what I did is I typed in cd for change directory, space, full stop, and then I executed the ls, which is the list command. So now, if I do the print working directory, I'm at the root of this operating system. We want to initiate to the user directory. So if we see, this is the user. So what we're going to do is we're going to type in cd for change directory. We use the /, and then we're going to type in u. Once we type in u, we will use the autocomplete feature within Linux. And in order to initiate this, after we press u, we're going to press on the tab key on our keyboard. So tab, and what happened is the S and R symbols were automatically completed. The reason being is, if you notice here, there is only one file with a unique name starting with U. So when we hit tab, we automatically completed the SR because there isn't another match with the same name. Let's do something else. If you notice here, we have the OP folder and OPT. So if instead of USR, we type in O, and then we hit tab, so again, O and tab, we're going to see P. Well, at this point is because there's two files with, or folders with the same name. What we can do is, because they're two results with matching names, we can do tab, which I did twice here, that's why I show it this way. We will reveal that these are our available options. If you notice, these two folders have the same start of their name, but the third character is different for this one. So when we hit tab the first time, we auto-complete it to OP because this is the last matching element. If we want to use the T folder, then we need to specify OPT and press tab. This is also a verification feature. If you want to check and make sure that you've typed in the file name, the folder name, whatever the case correctly, when you hit tab, you should see automatic / if you completed the name of the folder you're trying to specify. So in this case, we specified the correct folder, and we digressed a little bit. So we went into basically showing the USR folder. So let's go back to USR. We're over here in the graphical user interface inside the USR folder. So cd USR. Okay, we're inside. If you notice on the command line interface, once we're inside the folder, we don't see the content just like we see it within this Explorer window. So what we need to do is manually initiate the list command to show the content. Okay? So what it did is actually listed the content. So we're inside the user folder, and now we need to get inside the share folder. So the share folder is right there, so we can do cd and type in S. Well, we can autocomplete directly because there are many matches with S. We're going to specify H, which is the share. Oh, and it says no matching file or directory. Okay. Yeah, and it doesn't allow us to get to this particular place. So if you notice here, what I executed is ls space -la. We're basically getting more detailed content for this USR directory, and we see that the share file is actually a directory. So what we have here is D, and the RWX are read, write, and execute. And what we have is for the world, the group, and the user itself. So the owner, we have information regarding the size, the date, and the time. So since we're inside the USR folder, what we did wrong is we were anticipating to use the share. But this is not a main folder. So what we had to do in this case is, since we're inside the USR, which is a / starting point, once we're inside that main folder, all we have to do is start share. So just type in the name share, like this. In other words, what we could have done in the first place to get to the USR share folder to simulate what we have here is do this. We're going to start basically from the beginning. I type in a CD to get back to a starting point. So this is the root directory that we have. So we're gonna CD to back out of it. Okay, so now we are at the root directory. So in order to get to the user share from the command line, what we need to do is change directory, CD /USR, and then share. We hit tab, autocomplete, voila. Okay, so now we're listing the contents of this share folder. And if you notice, I typed in ls, and there's so many matches. There's actually there's so much content inside the folder that once we executed the command, it quickly scrolled through all the contents and filled up our screen. So there's just way too much content. So yes, we can use the little scroll bars to navigate through using the graphical user interface, and perhaps the command line interface using the scroll bars here. However, the command line interface, perhaps in this case, has one advantage. We can display the content one page at a time by piping the more command. So what we can do is, when we initiate the list command, we can use the pipe symbol, which is just a straight line, and then we can type in more. And what we're doing in this case is we're displaying one page at a time. So ls pipe more. What happens is one screen, one page at a time. We hit enter. We're going at more content and more content and more content. One screen, one page at a time. If you'd like to exit, press Q. We're out. Okay, so we started by talking about the main file structure of the operating system. So these are the main folders All of this content can be accessed using the Explorer or the command line interface. Some advantages of using the graphical user interface is that it's easier to navigate. Some people are visual and more familiar from a Windows environment, so it makes sense. Sometimes the command line interface has advantages from a programming perspective, for example. It's faster if you know actually where you're going and what the names of the particular files or folders are. And it can be used for automating repetitive tasks. So instead of double clicking on a folder file or executing something, we can use the command line with a command, put it in a script, and automate these tasks. So in some cases, we are going to be using the graphical user interface. In other cases, the command line interface. Both of them are very valuable, so we need to be familiar with both. This being said, this was kind of the basic structure in the organization of Linux. So there's some helpful reference guides with respect to getting started with Linux, surviving Linux. So what we're going to do is we can go to these just to show you and give you into perspective. The Linux survival website is a very valuable resource. The lessons are basically presented in the form of modules. So you have module 1, 2, and 4, each with different objectives. So in this way, you're going through the directory structure and kind of walks through the same process that I did. With the difference that these resources are providing a lot more detail, and you're going to be able to spend a lot more time learning about the file structure and the different intricacies of the operating system. Another resource that I would like to share with you is this one here. And it looks like it's a little bit different resource. So this particular one is for a command line foo. So it shows you the capability of the different tools that are available within the Linux operating system. So these are different commands. And the command line foo is the combination of these commands to provide tasks that, solve different problems. Maybe showing running processes, count, close, wait, time, wait. It's just a clever way of combining different command line utilities and switches to provide desired result. So this is one of them. I think this is a different resource. I think the hyperlinks were actually incorrect. So if we go to this resource, yeah, it's an introduction to Linux. So it looks like my hyperlinks were linked incorrectly. So we're going actually to this side right here, and I'll provide some links outside of the video demonstration to help you navigate to these resources. So Introduction to Linux, it's a hands-on guide. This is perhaps a different representation. It seems to be more one screen at a time, one module at a time. It has more text and different explanation. It's a complement to the first guide that I provided. The third one, and it looks like the reference to this one is also incorrect, so I'm going to copy the URL, paste directly here. Looks like when I pasted a bullet, so I had to go in through the Google suggestion and get to here. So it really, this reference is more talking about the different shells. So the shell is basically the living environment for the user. Shell is basically all the commands, all the interaction with the operating system is going to be done through this special instruction window called a shell. And the most common one is bash, or born again shell. So this particular reference shows how can you identify which shell actually you're using. It starts with some basic commands like the change directory, print working directory, absolute as opposed to relative paths, and so on. So very useful tutorials. Highly encourage you to revisit them. It's not a bad thing even for people that are familiar with them to review from time to time. Okay, so we've covered some of the fundamental Linux structure objectives. We're going to go into experimenting with some basic commands that will provide some type of information regarding the system. So what we'll do is leverage the uname command. So if in a command line window, so we can open up a new one. And by the way, if you look into your bottom right hand corner, you notice workspaces. There's 1, 2, 3, 4 workspaces indicated by this number in the upper right hand corner right here. So if you left click on them, you notice that these are identical environments of your desktop. What this allows you to do is multitasking. So you can have a window here, you can have a window here with perhaps a different task or application running. It's oriented towards this multitasking process. In Windows, this comparative is done through the desktop application from the sysinternal suite. For a headless server, so without this luxury of graphical user interface, we can use the screen command, which we'll cover in more detail a little bit later on. So the reason why I showed you this is we can go to a different workspace, leave what we were doing here, start fresh and clean, or we can just reclose and open up. So we're here in the second workspace, and we're going to execute the uname command. Once we do this, we're getting a basic information about our host name. So in this case, the uname command is providing the system information. So the system information available at this time was just Linux. Now if we use uname -all, or actually let's do -a, now we see Linux Kali, so it's displaying all of the content. You see that it's a Debian flavor. We see the date that perhaps it was compiled. So it's not just telling us maybe it was Linux. It's just a version of Linux as a pointer to the system information. It's telling us a lot more details. So if we're not sure how to reference the uname command, what we can use is the built-in manual pages for Linux. They can be accessed using the man command. So man is short for manual. So if we do man uname, now we can see actually what this command means. It's actually print system information. And I was misled. It was the host name for whatever reason. So print system information, a great reminder. So the way we navigate through this interface is we simply press the enter key on our keyboard, and it allows us to scroll a bit at a time. So each command is going to have a description, a basic usage. So as we saw here, it says uname and then option. And here are the available options. So we use -a for all. It says print all information in the following order except omit. So the is going to have the kernel name, the node name, kernel release, machine hardware name. These are different options we can specify: processor, hardware platform, operating system, and so on. So if we hit the Q, we're going to actually exit. So this is an outline of these different options that were listed there. So AMD64 was the processor, and essentially the command walks through and explains what each of these options are. And by the way, what I did, I used the up arrow on my keyboard like this, up arrow, and it was able to show me what was the last command that I've executed. So the last command was man uname, and what I did again, we start from this point, up arrow, man uname came up, then I hit enter, I come up back to this menu. So the kernel name was the first bit of information, the node name, kernel release, and so on. So essentially this is the information right here. Actually starting right here. Okay. So this is one way to look up information about a particular application. Not all applications will have a help file that can be referenced or accessed by using this man command. Some applications may have a built-in help menu. To access this, what we can do usually is use the -h option. So in this case, we're going to leverage the nmap command with -h. What happened is we got the file menu. Now sometimes, as I mentioned, there's going to be too much content per one screen or page. So what we can do to review one page at a time, we're going to leverage the more command. So we used nmap. I'm going to go back, maybe did that too quickly. Nmap -h, pipe more, hit enter, and we are up in this menu. So the basic usage of the nmap command is revealed here. You have target specification, and these are just different options within the application. In the bottom left hand corner we have more. To access more on the screen we hit enter. We continue hitting enter to reveal more of this content. Basically scrollable so that we can manage one screen at a time. And look at usually at the bottom, not for all applications but for some, you're given an example on how to use the utility. So in this case nmap, you have -v, -a, and then scan me nmap.org, which is the target. So the way I know what -a is, I go back here. So -a I reference as an option. I go back into my help file and look what -a is. It says enable OS detection, version detection, script scanning, and so on. So these examples are very helpful to help you understand the syntax, the contents of these commands, so that perhaps you can later start compiling your own and completing some of the assignment objectives. Okay, so we covered the uname command. Let's see. Oh, we'd like to see a detailed OS information. And how we do that? Well, there's a different approach. What we can do is we can use the cat command. The cat command is kind of like used as a view, but it's really a concatenation. And what we're going to do is we're going to use cat to view the contents of the ITSI issue folder. So the ITSI folder, or so like some people call it ETC, is a very important folder. A lot of critical files are located in there. And these critical files are usually configuration files. So in this case, we're going to access the ITSI issue, and we're going to find out more information about this particular instance of the operating system. It tells us a particular issue of the operating system. Okay, so after this, let's see what our next objective is. Review the uname. Okay, gonna cross that off. So after the uname, let's see, we're gonna review some host and user information. Host information, well, we can start with the host name. We can do this by typing in host name. In this case, it's called Cali. And that's why I was confused when I looked up here at the very beginning when I executed the uname. Cali. Okay, so the next thing we're going to look into is, let's see, maybe who's logged in. And we can do this by executing W. W is short for a version of who. So W, and it tells us that we have several sessions. And these are the terminal sessions that we have running. We have one, the W command is executed in, which is correct. We have another one running bash, and we have a third one with GDSM sensor. So there's a background process. So the next thing we can do is we can see user information. So for the current user of these initiated sessions, we can do who, and it tells us. So these are the particular the ones that were initiated by me. Let's see, if we'd like to find out who is the currently logged in user, we can use who am I, in this case root. If we use the let's think, ID command, that will provide basically the identity for the current user with respect to membership through different groups. Now, maybe what we'd like to do is find the last logged in user. So the way we can do this is reviewing the last-a, and whoa, that's too much information. Okay, so in this case what we can do is we can use the more command, or perhaps we can use head, only show the top content. So if you notice, this is July 12, we're in January, this is last year, so at the very bottom it seems like is the earliest type of information, so at the very top must be the latest. So what we can do is we can pipe our command with head, so last pipe with head, and see what the results are. So it looks like that these are the currently logged in users, and they're still logged in, so we have active sessions with these terminals. Okay, so now that we've reviewed some of the host and user information using the command line, we're going to jump into some processes. So what is the difference between a process and a service? It's kind of an interesting thing. They're related, yet they're different. So a process is an instance of an application. So the terminal is basically having its own process. A service is an application executable that runs in the background. So for example, we have a service like MySQL, which is a database. Some application needs to use it on the front end, but the actual database is running in the back end. It doesn't need to be visible. It just needs to be started and functional. So the service is usually associated with the background running process. It could be a database. It could be something that provides more functionality than just an instance for a user. And a process is a single, usually instance of an application running in the user space. Okay, so going back to this, we're going to review processes. And the most common command for this is going to be the PS command. Okay? So the PS command, essentially what it does is, let's look it up. It's printing a snapshot of a current process, of process or an instance of an application that's currently running. So man PS, report a snapshot of a current process. Great. So to leverage this, we can simply type in PS, and that's what's running. However, we can put in some parameters that can help us perhaps get some more information. So let's leverage PS and specify, for example, EDF. What we're doing with this is we're telling it select all processes in a full format listing, essentially. So what this does is, it looks like it's too much information, so let's pipe it with more. So it gives us the UID, the universal ID, the process ID, the PPID, some of the time components, and the actual command that's associated with this process. So if you notice, each process has a unique process ID. We can terminate a process based on this unique ID. There aren't two processes with the same ID. Otherwise, that'll be something suspicious we should look into. So let's exit out of here and grab, for example, grab the terminal that we are running in. Let's find out what process ID it's actually associated with. So we're going to execute, we're going to do the PS, so execute PS, EDF, and then we're going to pipe it with the grep command. The grep command is kind of, you can think of it as a search. It's an intelligent search. So we're going to grep the keyword terminal, so the string terminal. Grep terminal, and let's see what the results are. So the information that we have displayed is that the terminal application is running with process ID 6520. Let's see what happens if we actually terminate this one. And the reason I know it's the one that we're using because we executed grep terminal. Okay. So the way we can do this is using the kill command. Kill 9 is kill basically all. And then we're going to specify the process ID, which in this case should be the 6520. And what happens is we actually terminated our window. Because if you remember, we went in and identified what is the process ID for our terminal that we were running in. We identified it as 6520, and then we used the kill command to terminate it. This can be useful, so if you notice a suspicious service, it could be a way to terminate this application. When we are talking about ports and services, so ports are associated with services. Often to close a port, you need to terminate the service. And you terminate the service by identifying its process ID and then using things like the kill command or fuser, or perhaps other approaches to terminate the process and therefore close the port associated with it. Okay, so this was regarding processes and identifying them using the command line. So the next objective is perhaps review some services as well as application packages. So one way to do this is we can use the service command. So by initiating the service command, we're seeing like what is the syntax of this command. So let's see if there are any built-in switches for help. Yep, that's the only help. Or if we do the manual page service, okay, now it gives us basically a little bit more information. We see that one of the examples is the status all command. Okay, so what happens when we execute this? So what we can do is execute service, and then we're going to do -- status - all. What we're doing with this is we're using the initialization script for all of these services, and we're displaying their status in alphabetical order. So that's a whole lot of information, and since it's listing all running services, so what we're going to do is, again, we can pipe this with more and then show a little bit less at the time. Now you noticed perhaps that in these brackets you have minus, question. If you use a little bit more here, you have some pluses. Now each of these actually means something. The meaning is that the minus or the dash is indicative of a stop service. Okay, so in this case, NFS common be stopped, Nginx will be stopped, NTP will be stopped. The plus sign, however, is indicative of the fact that the service has been started. So OpenVM tools in this particular example has been started. However, you have some services that are listed with a question mark. The question mark is a little bit more intricate. So what the question mark means is that we have to use the upstart. Basically, the service was initiated with the upstart command. So the way that we can find out if this particular service is started is a little bit different approach. What we need to do is execute sudo. Sudo is kind of from the Windows environment, run as. Run as a different user. Run as a user with elevated privileges. Now, sudo, in order to actually execute it, you have to be a member of a particular sudoers group that has these elevated privileges that you perhaps are not administrator or root by default, but you can elevate your privileges on demand to execute some privileged tasks. So if we just do for kicks sudo, and then we execute init, and then ctl, then list, and it looks like I mistyped the command. Init ctl list. No. And it's not recognized. I'll have to follow up on this particular lead. And find out why is it really not working. Okay, so it looks like the initctl upstart command is not available in Kali, at least in the distribution that I have. So for the sake of the demonstration and move forward, what we're going to do is log into the target VM that you have. It's probably going to have a different name, but perhaps it's going to have the same screen like this. So we are log in with the assigned credentials. And then what we're going to do is we're going to execute this same command. So the service status all. And it looks like in this particular instance, the service command is not installed. However, what we're going to do is we will use the command we weren't able to use in Kali, which is the sudo initctl list. So sudo init ctl list, we'll be able to see the list with running processes. So this is to tell you that some instances of the operating system may or may not have all the packages that you need, all applications installed, and this is typical. There will be different commands. Some of them are going to be applicable through basically across all operating systems. Some of them may not. So you just have to, I guess, customize and be cautious of which command, for which flavor of the operating system. Most of them, again, will be the same. Some of them will be different, and this is one example. So after reviewing this services command, let's go in and perhaps take a look at some installed packages. So if we go in to the Kali machine and we use the package command, so the dpkg, essentially it's an application that helps us to build, manage, install different applications, and really low-level installations without any actual dependencies. So if we use the dpkg and then dash -l for list, we're going to see list with available packages. So these are things that essentially we can install. And again, the list is very detailed. Using the more, we can show a little bit at a time. We can actually, scroll through a screen at a time to, manage basically the view of the whole content of this particular listing. So another thing that we can use is apt-get. So apt-get is very popular for the Debian as well as Ubuntu flavors of Linux. So the way that apt-get works is basically the same as the dpackage one that we just demonstrated, with some added bonuses. So it includes dependencies. So for example, if you have an application with different libraries, all of them should be included into this particular instance. So some typical commands are apt-get. So if you use update, which do not do, the machines that you've been provided, you've been given for your lab environment, are configured in a specific way. Either you're not going to be able to update, or you will be breaking some of the intended functionality for your environment. So again, do not hit enter and execute this command. This is something you can do if you're using your own instance of Kali in an environment outside of your classroom. So some interesting things that you can do is the way the apt-get command actually works is it's using a configuration file where the download references for any updates for any packages are hard-coded. This information is actually stored within the ITSI apt and then sources that list config file. So we're using the cat command to view the contents of this file. Let's do more so it's a little more manageable. Looks like we didn't need to. So what happens here, these are the regular repositories for different packages. There's sources, there's a bleeding edge. So what happens is sometimes when you're working with outdated operating system, you will be forced to update these repositories because they've changed. And using this file, you can actually do that. How can you edit a file? Well, using the command line, you can use a text editor like Nano, which let's go into etc apt sources list, and I'm using autocomplete, by the way, to type it in so fast. If we do this, this is a text editor. This one is relatively easy to use, allows you to move left, right, using the control and then caret, and then if you want to exit, you press X. If you want to justify J, if you want to do read, whereas, and so on. In this case, we're going to hit X, caret, or control caret X. And so control caret X, they have to be pressed at the same time. It's asking, do you want to save or cancel, so it can return to your operation. In this case, we're going to press N for no, and we're going to exit. If you'd like to edit a file using the graphic user interface, we navigate, for example, to the same folder. In this case, it's etc or ITSI. We're getting in there, and we're going to apt. From there, we're going into the sources list. So what we're going to do from here is right-click, open with, and in my case, perhaps we can use LeafPad. Okay, LeafPad, good to go. Another popular text editor is Vi. So etc apt sources list. We do this, we open it up in a read mode. So we press I for insert, We can come in and modify some of this content. It's a little bit harder to maneuver, but some people prefer it. And it's a little bit more perhaps complicated to use. To get out of here, what we need to do is press escape key and put the colon, Q for quit, W for write, and the exclamation part is basically forcing this command. So forcing to quit, or if we have W and this, it's forcing it to write. In our case, we're just going to quit, so there's no changes made. Okay, so this was basically the simulation regarding packages, updates, and stuff like this. So we're going to cross this off and move forward. Logs. So the next area we will visit is log files. So there are different configurations located into the RSys log file. The RSys log file basically will tell us what other logs are set up for our system. So logs are basically containing information like authentication, email, login, SQL database features, and other related. So these logs can give us information about activity, and perhaps in some instances provide attribution for attacker or certain file changes and so on. So all these files are located in the let's go to cat, and then the ITSI, RSys log D, and then conf, so the configuration file basically within this directory. And enter, and of course there's a whole lot to review. So we start at the beginning, so we hit enter. So it gives a little bit of information about where things are located. This basically using this symbol, number sign, basically it's a comment to tell us what the information is about, so what the section is about. So over here we have some information. We're scrolling down, different rules, and look at this, log by facility. So authentication privileges are going to be located in this log, and this is the location for the log. Now if you pay attention, you have a similarity for the location of these logs. var log seems to be a common place for all of these different types of logs. You have user, mail, printer, kernel, services, scheduled tasks, system logging, and then the authentication log. So the importance of this file is the fact that it actually shows us where the other log files are located. So if we press Q, quit. So yeah, it's kind of interesting, information that we can leverage during analysis of a particular host. Okay, so in addition to this, let's see, we can probably leverage the fact that Kali has a built-in log interface. It's a little more graphical. So if we go to applications, so applications, system tools, let's see where it is, a log file viewer. So graphic user interface without this, actually in the system without the graphical user interface, you're not going to have this luxury. In this case we do, so we can view the content of these log files in a more dynamic type fashion. Okay, so this is kind of a current view, automatic scrolling, all that good stuff. From a command line perspective, and this comes to mind, is when you're reviewing a log, let's say for example the authentication log or the user log, what we can do is, it's really helpful to use the tailf command and then monitor the log activity. So in this case, let's do user.log. So what's happening is, in real time, we're monitoring the log using the tailf command. So basically display the last changes for this particular log. So at any time there is a change here, it's going to pop up at the bottom. So this helps us to actively monitor the state and the changes of perhaps different files, in this case logs. Okay, so Control C, we punt, basically we terminate the process or the task, and we move on. Let's see, so this was about the logs. Now we're going to get into a bit of fun. And I think I'm going to interrupt this tutorial and break it off because I think that I'm probably getting into about close to an hour. So I'm going to break it off and get into a different tutorial to catch on the second part of this, I guess, demonstration.